Hi there, welcome back to the King TUT class. In today's class, we'll be looking at calculating angular distances. And this will be looking at questions in latitude and longitude. Now, we have 4 questions here that I've pulled out. I'll be answering these questions with 2 basic methods. The first one is angular method, that's diagram. Second one is mathematically. Okay, so let's dive into the topic very quickly. Now, solution. Number 1 says find the angular distance between A and B. We have 2 points. We have point A and we have point what? Point B. Now, A has its values, B has its values. Now, note, in latitude and longitude, just like in graphs, we have x, y coordinates. Now, in this case, x started first, y came next. In this case, latitude must always start before longitude now come in place. That is latitude, longitude, just as x, y. Now, you notice or remember that my latitude is what, along the north-south region. So this is east-west for longitude, north-south region for latitude, east-west for what? For longitude. Now, that's not where we're going to, but you need to know that very much well. Now, another thing you need to notice is this. To answer questions in latitude and longitude, this initial part, you need to notice something. In this case, you can see that I have 65° east, 65° east. I have 40° north, I have 35° south. Now, according to my pole formula, we're either to add or subtract, right? Now, how will you know which you're going to add or which you're going to subtract? Very simple. Now, the thing we are basic about, or the thing that concerns us, is the values of the degree values. Now, the ones that has the same value, you eliminate. I mean, the points which the point A and B that has the same value, like this 65. For number 2 now, we have what? 20. I'm not considering the poles. I'm considering the values. In this case, number 4, we have 12. Now, okay, what you can see for number 3, we have something different actually. So, but what I'm more concerned about now is what is the values of the degree that determines what I'm going to do. Now, looking at this, since they have the same value of degree, you eliminate it, assume it does not exist. So what am I now considered about is what the remaining ones, 40 and what 35. Now, this is 40° north, this is 35° what? South. Now, north, south, they are opposite what? Opposite poles. So I'm going to what? Add. In that case, mathematically, number 1, the mathematical solution, what do I have? I'm going to have what? The difference, in region becomes what? 40 plus what? 35. That's 40 degrees plus what? 35 degrees. And my answer is what? 75 degrees. Very simple. Number two, or let me solve it diagrammatically now. Now, diagrammatically, what will I have? What I'm going to have is something of this form. Let's look at this diagram very closely. This is my what? GMT, and this is my what? Equator. Remember, 0 degrees, 0 degrees. How does it now become? Now, from those first question, A is 40° north, 65° east. 40° north, remember 40 is around this point, is up. So I have 40° north. Then I have 65° east. This is east. So 65° will go somewhat that far. So let me label this 65° east. Remember, you can label it any angle or at any angle. Then what do we have next? We have 35° south and 65° east. 35° south, this is south, so I can come like this. This is what? 35° south, and what? 65° is still this line here. Now let's go into the diagram very closely. Look at this. What I'm concerned about is what? These 3 lines. These 3 lines. Now, where the latitude and longitude meets, that becomes your first point. I have 40° north and what? 65° east. This is my point what? My point A. Pardon me. Coming. Okay, now This is my point what? This is my point A. Okay, for my question, yes, that's my point A. For the second one, this is 35° south, 65° east. Where they meet again is what? My point what? Point B. Now, what will I do with this point? You will trace the points to the center. That's to the point where my Greenwich meridian and my equator meets. Don't get it confused. Be very careful. Or just pay attention. This is my 40° north. This is my 35° south. This is 65° east, which is common to what? Both these lines of what? Latitude. Now, this is the center of the whole graph or the whole diagram. You trace the center to that point of intersection. Trace this center also to that what? Point of what? Intersection. Now, it simply implies that what? From here to here is what? Is 40. From here to here is what? Is 35. Now, if from here to here is 40, from here to here is 35, what does it imply? It means from here down to this point becomes what? 40 plus 35. Yes, it's just as though here to here is 40, here to here is 35. What's the total distance? That becomes what? 40 plus 35, which is what? 75. That's the first diagram. Now, number two, quickly. Number two question says what? P and Q are two places on the same circle of latitude what? Okay, sorry. That's number three. Number two question says find the distance between X and Y, where X is what? 60° north, 20° west, and Y is 40° north, 20° west. What do you notice? You notice that the values of these longitudes are what? The same thing. Okay. Now, in this case, what does that imply? It implies I'm going to eliminate this and then concentrate on what? These guys. Now, you can see that the poles of these ones are the same thing. Right? The poles are the same, the values are the same. This one, the poles are the same, the values are different. So the ones whose values are the same, you eliminate, concentrate on what? The other ones. Now, this is not. They are like terms. So I'm going to, like poles, so I'm going to what? Subtract. So mathematically, what will I have? Mathematically, I'm going to have what? 60 minus what? 40. That's the bigger minus the smaller. So it's not the other way around. So that's 40 minus 60 minus 40, that's what? 20 degrees. So, and whichever comes first, if 40 was also up and 60 was down, it will still be 60 minus 40. Okay, so the value is what? 20 degrees. Now let's see it diagrammatically. What I have is this. Okay, point X is what? 60° north, 20° west. So point X is 60° north, 20° west, 0 degrees, 0 degrees, 60° north around this point, 20° west. So very close because it's not really far from. Okay, so this is 20 degree west, and also I now have what? 40° north, 20° west. 40° north is at this point. 20° west is still this guy. Okay, this is 40° north, assuming. Now going into the diagram again, what do I have? What I have is this. This is the point. This is my point X. This is my point what? Y. Again, trace them to what? Trace them to the center. Trace this to the center. This is the center. Nowhere else. This is also what? The center. Now, what does it mean? It implies, looking at the diagram very well, that from here to this point X to this line is 60 degrees. Now, how am I getting this? Very simple. I'm tracing to my origin. For this first one, you can see that I trace it from this point of intersection to the origin, which is to the origin. That's my A. My B is from this point to the origin. That's my B. Now my X is from the point of intersection of X to where? The origin. So it means from here all through to this point is what? X, which is what? 60 degrees. And then Y is this point of intersection to this small place, which is what? Y. And that's what? 40 degrees. I'm now to look for distance between what? X and Y. Distance between X and Y is this remaining part. So in simple terms, if X is from here to here and Y is this small one, how will I get this one? It's by saying what? 60 minus what? 40. As simple as what? That. So in that case, I'm going to have my degree, my value as what 60 minus 40, which is what 20 degrees. The same thing happens here. That's what this one was, what 40 plus what 35, which is what, which is 75 degrees. Now, as simple as what, as simple as this. Now for the main two question, try it out and then let me get to know your answer. If you cannot get it out, I'm going to solve it in my next video.